Hi students, I am Rene Descartes. In the channel Classes with I Learn, you know it already, it is your channel. So to continue our study with the analytical geometry, we have already taken a part of it. Now today is section formula. Okay. Now what is a section formula? Say there are 2 points P and Q. We have placed them on a Cartesian reference frame of xo, x dash and yo, y dash. So the position of the points or the coordinates of the points P is x1, y1 and Q is x2, y2. Let us say that R is a point in between these 2 points P and Q having a coordinate xy. Now this has intersected the length between the points P and Q in the ratio m and n. To be more precise, PR is to RQ is m is to n. Now what we are going to do? We are going to find out the coordinates of R, that is x and y, in terms of x1, y1 known to us, x2, y2 known to us, and the given ratio m and n. So this we are going to find out. Now, first of all, what you want to do is that you drop some 3 perpendiculars from P, PL, from R it is RM, and from Q it is QN. Once again, let you drop some another 2 perpendicular PS on RM, and from R it is RT over QN. Okay, this is your construction. So by easy observation you can now see that OL equals to x1, OM is equal to x2, and ON is equal to x. This is x and this is x2. OL x1, OM x, and ON is x2. Similarly, PL is y1, RM is y, and QN is y2. By simple geometry, this RS is y minus y1 and Q2 is y2 minus y1. Now, take these 2 triangles, namely PSR and your RTQ. These 2 triangles are similar. It's a sign of or a symbol of similarity. Okay. Now, why similar? Because these angles are 90 degree, and because these and these and these are parallel, and this is the transversal. So this angle is equal to this angle. This angle is equal to this angle, and they are corresponding angles. So if any 2 angles are similar, equal to the other 2 angles of the triangles, then the third angle is obviously equal, and thereupon by the angle similarity, you get that PSR and RQT are similar triangles. Now, what are the properties of similar triangles? You may have read. So, the ratio of the corresponding sides will be equal. Okay. Now, you see Ln, that happens to be PS, and this is x minus x1, and here it is x2 minus x. So, we are taking a ratio. X minus x1 upon m equals to x2 minus x1 upon m. Then by simple simplification, you are cross multiplying. Mx2 minus mx is equal to nx minus nx1, and that way m plus n whole into x is equal to mx2 plus nx1, or x you get mx2 plus nx1 upon m plus n. So in a similar fashion, you can find out y also, y minus y upon m, that equals to y2 minus y upon n. So this way you get y is equal to m y2 plus n y1 by m plus 1. Now I give you a trick to remember this formula. First you write down these 2 points P x1 y1, Q x2 y2, and R is anywhere in between these 2 points, PQ, where its coordinates are xy. Then what you have to do is that m into x2 plus n into x1 upon m plus n, and similarly m y2 plus n y1 upon m plus n. So easy to remember, and there's a tricks to remember. Okay, you can mug up, better not to mug up. So then we go to the case analysis. What is that? Had it been that R is the midpoint, that is your ratio of m and n is 1:1. That is R is the midpoint of that PQ. Then xy is equal to, what you have to do, you have to put the value of m1 and n1. This way it summarizes to x1 plus x2 by 2 and y1 plus y2 upon 2. Now let us take some illustrative example. Example 1. The question is, find the coordinates of the point which divides the segment joining the points 5, -2 and 9, 6 in the ratio 3:1. Everything is given, you know. That is your point x1, y1, x2, y2 and the ratio m and n, all are given. So let the required point be xy, the coordinate. Therefore x is equal to mx2 plus nx1 by m plus n and y is equal to my2 plus n into y1 by m plus n. So this equals to 4 and this comes down to 8. Therefore the required point is 8, 4. So easy. Next example. This wants that find the length of the median through A, that is the vertex of a triangle, you know, of a triangle whose vertices are A is 0, 4, B is 3 minus 3 and C is 3, 3. Okay. Now what is the median? You know it. That median is from the vertex to the midpoint of the base, the line that is segmented from the vertex to the midpoint of the base. So let you take the midpoint of the base, BC is D. So once again that formula already you have done, x1 plus x2 upon 2 and y1 plus y2 upon 2. So it is 3 plus 3 upon 2 and minus 3 plus 3 over 2, that is 3, 0. So you get the midpoint of BC as D. You know the vertex is given to you, you know, it is 0, 4. So what you have to find out? You have to find out the distance, and you know the distance formula. Already we have discussed in your previous, video, analytical geometry part 1, and we have found out, you know the formula, that is x2 minus x1 whole square plus y2 minus y1 whole square whole under root. So just we have put that 3 minus 0 whole square plus 0 minus 4 whole square whole under root. So that comes down as 9 plus 16 under root, that is 25 under root, that equals to 5 units of length. Therefore the length of the median is simply 5 units of length. Now let us take another 2 examples, okay, before we end of this session. So example number 3. The line joining the points 2, 1 and 5 minus 8 is trisected at points P and Q. If point P lies on the line 2x minus y plus k equals to 0, then find the value of k. This is your problem. That is, the problem is to find out the value of k. Nice. So I have drawn a figure. Here the point A is 2, 1, the point B is 5 minus 8, and this is trisected between the points P and Q. What do you mean by trisected, Or in simple words, AP is to PB, that equals to 1:2. This is the meaning of the trisection. That is, AP is to BP is equal to 1:2. So by our section formula, you can easily find out the coordinates of the point of P. You know it, mx2 plus and x1, etc. So 5 into 1 plus 2 into 2 by 1 plus 2, and here it is minus 8 into 1 plus 2 into 1 upon 1 plus 2. Similarly, if you calculate it, this comes down to 3 minus 2, right? Now by problem, this point P is lying on the straight line, that is 2x minus y plus k equals to 0. As it lies on the straight line, so that is going to satisfy the equation. Therefore 2 into 3 minus 2 plus k equals to 0, or if you calculate it, it becomes k equals to minus 8. That is, the required value of k is minus 8. Finished. Now come down to the example number 4. What is the question there? The question is, determine the ratio in which a straight line, y minus x plus 2 equals to 0, that divides the line joining these 2 points 3 minus 1 and 8, 9. Okay? This is your question. That is, here the question is, there are 2 points and 1 line. This line has intersected the join of these 2 points. What are the points? It is given 3 minus 1 and 8, 9. And what is the line? That is also given. Okay? Let the line divides the line segment joining 3 minus 1 and 8, 9 in the ratio lambda is to 1. This is your lambda, L-A-M-B-D-A. It's a Greek alphabet. Lambda. Lambda is to 1. Therefore, P is equal to, by the section formula, 8 lambda plus 3 by lambda plus 1, 9 lambda minus 1 by lambda plus 1. 9 lambda minus 1 upon lambda plus 1. But this point P is lying on the straight line, this y minus x plus 2 equals to 0. And you just put the coordinates of the x and y into this given equation. That is 9 lambda minus 1 upon lambda plus 1 minus 8 lambda plus 3 upon lambda plus 1 plus 2 is equal to 0. Very simple equation to do it, Just you solve it and you get 3 lambda minus 2 equals to 0 and lambda is equal to 2 by 3. Therefore, the required ratio is 2 by 3 is to 1. That is, if you make it a simple ratio, multiply both with 3 and then it becomes 2 is to 3. That is, it is intersecting the joints of the points internally. Why? Because if lambda becomes greater than 0, that is positive, then it is internally segment. So the required ratio is 2 is to 3. So it is done. Okay. Now before I end this session, once again I will be requesting your favor to subscribe, to share, to like this channel, Classes with I Learn, and take care, keep well and be with me. Thank you.